Hi viewers, welcome to the session 3 of electric circuits. In this session I wanted to deal with the problems related to Kirchoff's laws. Here I am considering an unbalanced Redstone bridge which is going to have the branch resistances 2 ohms, 4 ohms, 1 ohm and 3 ohms. We can observe that the bridge is not balanced, 2 by 1 is not equal to 4 by 3. Hence a small amount of current will pass through this branch B and D, in between which the galvanometer is going to be connected having a resistance of 8 ohms, and that is what actually we are asked to find out using Kirchoff's laws here. For that sake, what I should do is what I shall do here is, as a first part, I am going to assign the currents passing through all the branches. Here I am considering the current as I1 here and I2 here and I3 in this branch, flowing in the respective directions shown here. And once I1 and I3 flows in this way, the current passing through this branch IBC is given by I1 minus I3. Similarly, the current passing through DC is given by I2 plus I3. Like that, we have to represent all the currents passing through all the branches. And after the currents are represented, the next step is to find out the voltage drops in all the branches. I mean resistances. Here, the voltage drop is 2I1, 4 into I1 minus I3 here, 3 into I2 plus I3, 1 into I2 and 2 into I1 plus I2. And we need to assign the signs also for the voltage drop in each resistance. For that, we know the set of rules, that is, the positive sign will be assigned at the terminal where the current is going to enter. So depending on that, the 2I1 is going to, this voltage drop is going to have positive sign here and negative here. Similarly, 4 into I1 minus I3 is going to have positive sign onto this particular terminal and negative here, like that. Depending upon the terminal where the current enters, that particular terminal is assigned as positive sign. So after once assigned all these signs for the voltage drops, now we can implement Kirchoff's voltage law to this particular problem. I mean loops where we have to write down the equations. So that part we shall do with our PowerPoint presentation, which is going to be shown now.
Let us come to the solution part. Already we have assigned the currents in each branch, and also we have found out the voltage drops in each resistance. Now let us apply Kirchoff's voltage law to loop ABDA. That implies 2I1 plus 8I3 minus I2 is equal to 0. Here 8I3 is considered as the same sign as that of 2I1 because opposite terminals are connected. Similarly, I2 is given negative sign as the similar terminals, that is minus and minus, are connected. Hence it has got the opposite sign as that of the previous source, that is 8I3. So these set of guidelines that we have framed in our session 2. In the same way, apply Kirchoff's voltage law to the loop BCDB. We get the equation as 4 into I1 minus I3, here it is taken as the reference, minus 3 into I2 plus I3 minus 8I3 is equal to 0. Follow the same rules that we have considered. After simplifying, we get the equation as 4I1 minus 3I2 minus 15I3 is equal to 0. Here we have considered the two loops ABDA and BCDB, which have got no sources, but the third equation we are going to select that should have source. Otherwise, the right hand side for the three equations become equal to 0. That leads to no solution. Hence, it is compulsory for us now to take the third loop, which consisting of the source. Hence, I am considering here the loop ADCA. Now apply KVL to that. We get 4 minus I2 minus 3 into I2 plus I3 minus 2 into I1 plus I2 is equal to 0. After simplification, we get 2I1 plus 6I2 plus 3I3 is equal to 4. Now I am writing down all these three equations at one place such that I1 terms, next I2 and then I3 terms for each equation. After writing down, in order to solve these equations, here I am using Cramer's method. First, write down the basic metric equation for the above three equation. It becomes 2 minus 1, 8, 4 minus 3 minus 15, 2, 6, 3 multiplied by I1, I2, I3 is equal to 0, 0, 4. Here, the basic matrix has been formed by considering the coefficients of I1, I2 and I3 respectively in each equation. And once this equation has been formed, we are asked to find out I3, which will be equal to delta 3 by delta, and we need to find out the values of delta 3 and delta here. Let us see. Delta means the determinant of the basic matrix that we have formed earlier, which gives rise to the value of 444. I hope that all of you know how to expand or how to evaluate the value of this determinant for a 3 by 3 matrix. Similarly, we find out the determinant of delta 3 by replacing the third row with the right hand side values. Here delta 3 is, we have got the value as minus 8. Once you evaluate these two values, find out the value of I3 as equal to delta 3 by delta, that is minus 8 by 444, which gives rise to minus 0.018, which is equal to 18 milliamperes. So this completes the solution. Finally, the current passing through the galvanometer is equal to 18 milliamperes. This concludes this particular session.